or communication concerning that old system. We are officially switching to a new platform that you may be familiar with, Canvas by Instructure. For those new to Canvas, don't worry. A video tutorial will be uploaded to guide you step. Dear DSA students, we are so excited to be on this journey with you, and we want to say a big well done for your commitment and enthusiasm so far. Whether you have just joined or you have been learning with us over the past few weeks, we see your progress and we are rooting for you all the way. Now, we know there's been a bit of silence around the learning management system, and we sincerely apologize for that. But here's the good news. We have an update as regards the learning management system, and it is one you'll love. Some of you may have been onboarded on the previous LMS, but want to ask that you kindly disregard any previous link, platform, or communication concerning that old system. We are officially switching to a new platform that you may be familiar with, Canvas by Instructure. For those new to Canvas, don't worry. A video tutorial will be uploaded to guide you step by step on how to use the platform effectively on our YouTube channel. You will also receive an onboarding email directly from Canvas by Instructure to help you get started. Please follow the instructions in the email and input your details to begin your learning journey on the platform. We are committed to making sure your learning experience is smooth, interactive, and impactful. So please, pay close attention to the announcements coming right after this video for more details. We are so glad to have you with us. Keep going, we've got this.
All right, good evening, everyone. Can you hear me? It's good to be back this evening. It's good to be back. How is everyone? How was our weekend? You can hear me, just reply and just wave. You can hear me, just give me the emoji wave so that I can know that you can hear me loud and clear. Oh, great, great, Samson. Good evening, good evening, Oluremi. Olashade, good evening. Testimony, good evening. Samson Abraham, good evening. Davis, good evening. John, good evening. Great, great, great. Eddie, good evening. It's good to have everyone here. Great, great. Okay, today we'll be looking at a linear regression concept, equations, and assumptions. Linear regression concept, equation, and assumptions. So we'll just diving into the slides this morning. Sorry, this evening. Okay, so welcome to the world of regression. So when we talk about regression, we want to talk about what predicting like predicting the future like what? Like a pro. We want to learn how machine use maths to make smart guesses, like predicting prices, grades, and trends. So that's what we're going to be doing this evening. We just want to look at the other type of what's it called models. Also, you have the classification model at itself also. So, but since we are talking about machine learning and AI, so we'll be looking at a regression model, which we'll be taking on next week. By the fifth week, we'll be talking about them as standalone. So we just want to talk about the regression world, and maybe look at if we're able to look at the classification world also, and also talk about so on Wednesday then we'll talk about how do you choose a model. All right, I can see everyone. I can see everyone. It's fantastic to have you here. It's fantastic to have everybody here. So great, 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 great. So this is fantastic. So let's go on. So we'll just be looking at regression work. All right. So what is a linear regression itself? What is linear regression? You want to predict your grade based on how many hours you studied. Exactly. So that's what we are looking at. So I'll be using the real life analogy. Just imagine that you want to predict your grade based on how many hours you are studying. So let's put it this way. We can decide to say, okay, if somebody studies between 10 to 12 hours per day for the next 2 weeks, if the person writes an exam, then the person should score between was maybe 80 or exactly maybe 80 to 85. So it means that anybody that does anything below that hours per week will score lower grade. So that's the way a regression model works. So predicting decision based on some particular what parameters. Okay, you can see grades based on how many hours you studied. Somebody will be looking at it. Is it possible? Yes, it's possible. It's possible to look at it that okay, for a set of it's an experiment. You can carry it out and decide okay, for a set of particular students, you want to see okay what made them better. Then we do like a what's it called a questionnaire exactly. It's not like a questionnaire to say okay, how long did you wait for? When did you do this? What did you do? Then we can actually somebody said interesting. Yes, Daniel is very interesting because that's the one good thing about this AIML we are talking about. You can create models that can forecast. You see, whether forecast models are there. So we just want to look. That's where this it comes from. Actually, getting an answer from a particular what criteria or characteristics. Exactly. So you look at it now. Why are Asians short? Is it based on their region or the food they eat and things? You can do a model like that also. Or why are Africans black? And things like that. So linear regression. That's a linear regression model. Predicting an outcome based on particular criteria. Somebody say quite interesting thought. Yes, it's a quite interesting thought, which is good. Which is good. All right. So it's a method to predict one thing, like what I've just been saying all through. Or target, you want to predict something from another thing, which is the future. Exactly. You are looking at okay, uh, Just okay, maybe you use somebody like me. Is it because I eat too much? Is that why I'm fat? Or is it because I sleep too much? Is that why I'm fat? Something like that. So that's the regression model, predicting an outcome from what some particular characteristics or what or features. So that's just a linear regression. All right. If I'm too fast, please let me know. I'll go very slow. If you need to ask question, put it in the chat box. Mr. Blessing is here with me. He will help me reply. So far, so good. If you are understanding what I'm saying, Daniel, you're laughing. Yeah, so maybe it's because I sleep too much or because I eat too much. Maybe that's why I'm fat. So it's a linear regression. We can write a model and say, okay, if he eats too much, what are the food that he eats that makes him fat? Or if he sleeps too much, how many hours does Mr. Olabide sleep that makes him fat? Something like that. Or is he hereditary? I heard something like that. So you can design a model and look at, everybody that comes from his line, it depends on your model. So you now begin to gather data concerning Mr. Olabide, and you can give me the result later. All right. So from where I've gone through, if you understand me, just give me a thumbs up, and I'll go on. I'm waiting for our responses so I can go on. Okay. Great, great, great. Somebody said is regression not something negative? We are talking about regression in machine learning using linear regression. We are talking about having an independent variable and an independent variable. Where the dependent variable is your target for the outcome, and your independent variable is the features. So predicting somebody's scores based on how many hours he studied can be based on just one independent variable or one or more. Just like the example I gave about myself, what is making Mr. Olajide fat? So we are looking at fat. Mr. Olajide being fat is what? Is the target. What is making him fat? Then what are the independent variables, which are the features? So the target is here, then the features. So it could be one, it could be more than one. Okay, great. I'm glad that we're following, so I can go on. Thank you very much. Thank you. So there's nothing negative about uh, linear regression. Thank you. Okay. So example, look at use case of linear regression. Like Spotify, he said it predicts songs you might like based on past plays. You notice that for those of us that are very avid on social media, especially your like TikTok, when it gets to a time, you realize that anytime you go onto your TikTok, it begins to give you some. Thank you very much. Yes, it's under supervised learning. Regression and classification are under supervised learning. So you are good. You are good. So thank you very much. It doesn't really focus on yes, it's not. It doesn't focus on negative. So it's just your dependent variable and your independent variable. So it can be an outcome for why people are failing. It can be an outcome for why people are passing. It can be an outcome for why this particular set of people are being sick of that. So look at the examples and the use case, like your Spotify that I was explaining to you. So you predict songs you might like based on what? On your past plays. Like I was giving the analogy concerning your what's it called? TikTok. You just realize that. Thank you very much, algorithm. That's fantastic. But let's just break it down so that we don't break people's heads. Some of us are already gurus in this. So for those of us that are just starting the class, so you see things they call like cookies or patterns. So cookies are like patterns, algorithms are like patterns. So what TikTok does is that it monitors your pattern. What are you doing? Oh, these are the kind of videos that Tony likes to watch all the time. You realize that for every time that Tony will log on to her TikTok, it begins to bring out those same kind of what of content that she usually likes to watch. Like someone like me now that likes to watch what's it called? Um there's this funny guy that I used to like following on TikTok. every time I come up there, I just see, hey, this guy that sang there, I just love this guy that sang there. That Ramadan song, I did the Ramadan song. So I noticed that lately, because during the Ramadan time, I kept on following his Ramadan song, the guy is falling dance there, be shaking his head this way and this funny things. So I noticed that for almost like a week or a month, Taliban, thank you very much, Taliban, thank you. Thank you so much. I noticed that anytime I open anything that has to do with him, it just keeps giving me those things because what? It has studied my pattern, has studied my, my usage. Oh, these are the things he has been checking for a long time. So somebody calls it algorithm. Some people call it cookies. So it's just what the system or the AI is just monitoring or trying to look at patterns or things that you like, that you're interested in so much, and it studies it and it stores it. So anytime you come in, it suggests it to you. For those of you on Netflix and this other one, Netflix and this other, I keep forgetting the name of this Amazon Prime, exactly, Amazon Prime. You realize that before you know it, it suggests movies to you. You find out that it just tells you, oh, look at this movie, Cookies, God bless you. I love that. So it just tells you, oh, there's a movie you have seen. So this other movie looks like, so you begin to see like things like Farah preferences, begin to study your preference, then it begins to suggest to you. So that's what is a linear regression model that we use to do that. Look at your Uber that estimates trip cost based on the distance. It's done with what linear regression. Take the map and study. Okay, from this point A to point B, maybe from redemption camp to Lekki Aja is about 46 kilometers. I might not be correct. So it looks at it and weighs it. Okay, if somebody travels for 46 kilometers, what should the billing look like? You'll find out that somebody who is traveling for 26 kilometers, your fee will be lesser than somebody who is traveling for 46 kilometers, somebody who is traveling higher than and that. And that's the same thing they've done in TFA for airlines also. You realize that for you traveling abroad to Europe, your T fare, your flight ticket or fare is different from somebody who is traveling to Australia, someone who is traveling to Canada, someone who is going to the US. So it's a different. So it's just a what? It's a what's it called? It's just a pattern. And linear regression does that so much. It does that so much. So that's what the idea about linear regression. Then the ETC vibes software that suggests courses related to your previously assessed courses. I'm sure that when we're coming for this DSA program, when you're coming for the DSA program, I'm sure that Incubator Hub would have sent you something like a questionnaire or a form for you to fill that will be used to assess, okay, what class do you fit into. So for those of us that found ourselves in AI and ML class, it means that what we met some criteria based on your preferences or the way you answer the question. So something like that. So suggesting to you that I have somebody that called me on Sunday and it was saying to me, he was saying to me, he said he wanted to take our AIML class, but he told him to go for graphics design. So I told him, I said, did you answer the question or was a questionnaire sent to you? He said yes. I said yes. So the questionnaire has assessed you. So this concept is applicable in cybersecurity called user entity and exactly. So something like that. Your user what please check your network. Like I've always told us, every time I I use my system, I have a second device. I can hear myself clear, clear. So please check your network. So that's what a linear regression model. That's what it does. All right. So those are just the examples. There are more examples, more examples. So look at your linear regression equation. Your linear regression equation. So it's a linear regression formula, which is y is equal to what? Equals to mx plus b y plus all right. Please hold on for me. Excuse me. Please, I need to take water. A bit of salt to just give me a few seconds. Let me take water. Okay, sorry for that break. Sorry for that. I have to just take water. My throat was a bit itchy. I have to stand up. All right. So your basic linear regression equation, which is your y is equal to mx plus b. I know somebody will be looking at me and be asking, which one is this again? As I told us, for everything we are doing in the AI and ML, there's a basis of statistics, there's a basis of physics, there's a basis of mathematics. So you don't know, you don't need to, how would I say, how do I say it to people? I say you don't need to know everything. Just have an idea of what is happening behind it. All right. So somebody will be asking me what is y is equal to mx plus b. So y now is your predicted value. For y is your what predicted value, which is the dependent variable. Like I told us when we are talking of linear regression, we're talking about the dependent variable, which is the target. Then the independent variable, which are the features or likable, what would I call it, characteristics that influences or gives you your target. So y means what your predicted. Okay, y, like I said, just the same example. Somebody said Mr. Ladiday it's not fat. Say it's a flop or something. I was laughing. So y, that is it. Fat. Then your x is your input or your feature or the characteristics, which is called the independent variable, like I've explained to us. Then n is the slope of the line. Somebody will say, which one is the slope of the line again? This is how much your y changes for each unit of change in x. Just calm down now. I will explain that my place very well now. I've told us y is dependent variable. If you're writing, y is your dependent variable. That is your output, your target. X is the independent variable. It can be either one or two. Then M now is not that slow. Like I said, what how much your Y changes for each time you add an X. Okay, now like me now looking at Mr. Lagide is this fast. Oh, somebody decides and says, I've done a linear regression model, and why Mr. Lagide is fat. Okay, it's because he eats so much and he sleeps so much. Then somebody now comes and say, Mr. Lagide can be fatter if not only if he eats so much and he sleeps so much. What if mm, let me see what I can do. Then he doesn't exercise. He doesn't exercise. So it means that he'll be fatter than what he is. So your output, your M is always showing the change in your output for every time an independent variable is added to what to that equation. So the more the independent variables are being added, the more what your x your y sorry changes. So that is what the n is signifying. Then b is just the intercept between your y and x. And most of the times this happens when x is always in zero. For your graph, when you have a graph, you're always having there's a place whereby x and y will always cross. And that region is always where what is called what that region is always zero for those of us in mathematics. You know that where x and y, when you have your graph this way, where x and y intersect is always at what at level zero. So that's just all what it means. Y is our predicted value, which is the dependent variable. You can call it your target, your outcome. X is your independent variable. You can call it your features, your inputs, your characteristics. M is the slope of the line from where there's a change for every time X changes. It affects Y. The more features you put, Y will change. Then B is just your intersection between Y and X and the what? And the graph axis. Is that good? Is that good? Somebody said it seems as if we be solving, we be plotting a graph. Yes, there's no way you will do such a thing that you will not plot graph. Statistics 101. Yes, you always. There are times we just need to know what's it called? Just the bit of equation behind it. What we are talking about. Okay, so it's here. Uh-huh. I didn't want to show you because if I showed you this one now, somebody will say, "I know you quickly see it." So it's always good to explain the concept before you see it. So everything is in our notes. It's in our notes. So you can see, say the Y you want to predict, which is your grade. Exactly. Then X, the input, hours studied, using that analogy that we just gave. Okay, somebody who has passed, how many hours, so things like that. Then your slope, how much grade goes up with each extra hour, you can see. And it can go down with every less hour. Then intercept, always your starting point. If you didn't study at all, you know now. So just imagine somebody who studied, somebody who didn't study will always score zero. Let's put it that way. Let's put it that way. So somebody who didn't study will always put it that way. So it's zero. You didn't study at all. So there's no amount of compassion or bashing or whatever you study. It's the slope of the line. Thank you very much. So it's not a slope. That's slope means the change. You know, we could go for those of us that did for economics then when you're looking at the demand curve, your demand curve. You know, the higher the propensity to spend, I think, yes. The higher the demand, exactly, the higher your propensity to spend. The lower your demand, the lower the propensity to spend. So that's the kind of M. So the M is what? For every time you add extra hours, your grade will go up. For every time you reduce your study hour, it was it will lose time. So that's why you can see linear, because it will always be in a straight line. See that it goes up or it's going this way. So that's just it. All right. Somebody is saying, can I? Yeah. So why is the target and S is the future? Yes, I said that already from the beginning. I think I've explained demand cost. Thank you very much. Demand cost. Thank you, promise. Thank you so much. Thank you. So when you are doing demand, you see it now. So that's just almost what it looks like. Yeah, also when you are talking about the linear regression. Just like when we talk about Newton's first law of motion. You say a body will continue to remain in the state of inertia unless it's being what? Affected by what? An external force. As an external force. So the body will always remain. So just like it for this, your M. Your M is telling you that what? For every time there's an input, what the grade will increase. And for every time an input is being reduced, the grade will also reduce. So it's just like that. All right. Okay. So what are the assumptions? There are some assumptions of a linear regression. Like as rules, regression works best when there's linearity. That is, the relationship is in a straight line. Now I've said it. It's always in a straight. It doesn't. If it's not in a straight line, it will not. It will not work. So what does it? These are assumptions. These are the assumptions. Anyway. These are the assumptions. Then non-multicollinearity. When variables aren't too similar, we believe that regression works best when the variables aren't too similar. Okay. Then there's homoscedasticity, which is the spread of residuals or errors, which is even. Exactly. Exactly. Then there's normal distribution of errors when residuals are symmetrically distributed. Then we talk about no autocorrelation when your predictions or errors are independent over time. So we said that these are the assumptions anyway. Yeah, assumptions. So just for every formula, for every theory, there are always assumptions. The straight line graph formula. It's as simple as that. Anything will always any theory will always be assumption. If you remember Darwin's theory of survival, remember the survival of the fittest now. So if you have three animals and so things like that, so there are always assumptions. Are we going to run any code? Yes, we work on this linear regression on Friday. Please let's just take care. Most of the times I would love us. I know you want to ask questions, but I've always enjoyed that we really pay attention because when you have this concept behind your mind, when you face some questions, that's what I'll be teaching on Wednesday also. When I'll be talking about when to choose models and when to choose the type of algorithms you need to use. You must understand some basics and more you need to help with them. So let's go on. So this is for us. List three things you think can be predicted using linear regression. And we just quickly do this in-house exercise. Let's list three things that you think you can predict using linear regression. At least I gave example of myself. Then on the slide, we gave example of student grades increasing based on what on how long the student has studied for. So can we all do this? I just need 10 people. Don't give me just one answer. I want three things. Three things. Don't you must add your three things in one line. If you just put only one, I won't pass you. Everybody must you must have three so you can enter, then you put three. Anyway, somebody say weather. Somebody has told me weather rate for that shadi. Weather revenue, profit over a certain period. That's great. Pregnancy chances. Oh, Babs, fantastic. Health man. I love that. Olu says nutritional health. I want you to don't just be writing prices. I want us to say so that I must see the dependent variable and the independent variable. It's not the way I gave you my own example. I said what? Grade increase based on hourly. Exactly. So I want something like that. Somebody said, I love this. He said weight versus fasting. Expatiate that your weight versus fasting. Football match in this game. Okay. The growth of a plant versus the number of hours that is sunshine. That's good. The distance and time of for air flight. That's great. Life expectancy, job opportunity. Great. Oh, you guys are wonderful. You guys are wonderful. We can predict sales income using advertising spending. Wow, that's good. That's good. Okay. Somebody says menstrual cycle. I love that. God's favorite. That's good. You see now that you are already creating what for yourself models that you can build. You can see now just with talking about linear regression already, you already have ideas. Now this is cause of diabetes. That's Mr. Blessing student. That's Mr. Blessing student. Somebody says ovulation, pregnancy. You can see now that a lot of things that happen in our day-to-day activities, fever symptoms, training and medication usage. Fantastic, fantastic. For Grace, football match, that's one expert and all of them. So you see, you are playing your true sure and whatever they play there. Agricultural activities based on weather forecast. Great. SMEs and value creation. Great. Students who are likely to leave class after marking attendance. Junior, that's fantastic. Growth of children or infant overfeeding. Oh my God, you guys are wonderful. You guys are wonderful. In fact, I can see that you guys are doing fine. Everybody, I'm just saying things that are similar movies you watch. Fantastic. Logistics services, land prices, transport costs. You guys are fantastic. In fact, good, good, good. So this is good. So you see that our day-to-day life activities, just imagine all these things you have mentioned. You have solutions for them. You find out that you don't need to go so far, spend so much. And that is what the good thing about AI and ML. The thing I love is that what we want to solve real life was pandemic. I love that pandemic approach. Yes, we can look at the environment and say, okay, the way people are constituting or the way people are dumping refuse can lead to an outbreak of pandemic over a period of time. It's fantastic. It's fantastic. It's fantastic. You guys are wonderful. So that's great. That's great. So let's go on with the slides. So I see that yes, you are really picking it, and I'm so we will soon have solutions to them, sir. Amen, Isaac. Amen. I love this. I love this. Battery, exactly what can lead to somebody's battery, some habits that can lead to death rate or over period of time or season and things like that. Fantastic. Your monthly expenditures, yes, for people that don't know how to save or spend, what are those habits that can lead to you having what being poor or things like that. So mortality and infants, fantastic. You guys are great. All right, let's go on. Let's go on. Everybody is correct. I'm very happy. I'm very excited that yeah, we are following. Okay, so I look at things we have mentioned. Somebody has mentioned something like this. Price of food items over time. How much will a bag of rice cost in 6 months? Look at the problem. Food prices are constantly increasing due to inflation or poor agricultural support and fuel costs. What is the prediction? You can create a linear regression model that can use past prices to predict what future ones, helping consumers and sellers to plan. Plan better. Yes, you are following Mrs. Craft. You are following with the Y in bracket. Yes, I love it. Everybody's following. I'm super proud of you. Super proud of you. So you can see things like that. So we can look at price, the way price hike has gone now. You can look at, okay, with what is happening in Nigeria. Somebody can even create a model for us, for regression model. In the next 6 months, what will the price of fuel be in Nigeria? That's a good model. That's a good model. You can look at it and go and take, okay, 10 years record, data set, and train and say, okay, your system should be able to predict in the next 6 months, in the next 1 year. Staff attrition, fantastic. So we can do things like that. Employment rate versus government spending on education. Yes, that's it. That this is it. Look at the ideas here now. So some of us, those of us that are very smart and sharp now, we should be picking our model topics. In fact, you should get ready now and start looking for your data. I think I was listening to Mr. Blessing was saying, begin to get your data set and things. By now, you should already be defining your problem statement and thinking of what you can do, what you can do. So if the government increase education funding, we need to reduce unemployment. So what is the problem statement? Youth unemployment is high due to poor education and skill gap. Then prediction, by analyzing past spending and unemployment trends, we can predict how changes in budget allocation what might improve job creation, the possibility of blood sugar rising. Great. National grid performance. Great. So everybody start thinking of and start looking for your data set. I'm happy. At this stage, if you guys are talking like this, then in fact our work is almost done. I'm really happy. Really happy. All right. Then I saw somebody spoke about electricity supply, so it's part of our slide also. And our population. Will the electricity supply meet Nigeria's population growth? Yes. Will electricity supply meet Nigeria's population growth? Frequent blackouts and power shortages affect productivity. So we can do a linear regression model that can estimate whether power generation is keeping up with population growth and helping policy makers to act fast. So I've always told us for every time you are talking MLAI, what is that problem around you? And I'm telling you, if you check your environment where you are staying, there are some problems that are around your environment and you can develop a model to solve. Exactly. So those are things. Everybody that has answered, have answered very, very well. Very, very well. Okay. So in fact, I think we have answered questions. So I won't do questions and short break because I see that we are all full in, so we'll just go on. But when it's 8 o'clock, we'll break so that we can sign our attendance and come back by 8:05 and we'll continue. So let's go on with our slides. Okay, so now understanding performance metrics. Yes, I told every one of us. I told them we're going to teach you guys performance metrics, which is very very necessary because if you don't know for every model there are different evaluation metrics. So anywhere you see performance metrics, it's also called what? Evaluation metrics. So for every time you are working with any model, each model for regression model, you have the performance metrics are different. For a classification model, the performance metrics are different. For a deep learning model, which are the unsupervised model, or we call them the cluster models or the clustering models. There are different types of what's it called? Evaluation metrics or performance metrics. So what do you do with these performance metrics? You measure is my system, is my model actually meeting the global range. Because before you saw the statement, before you can actually say your model is I keep on mentioning that word, generalizability, generalizability, generalizability. It's not enough for your model to solve your own problem, but can your model solve the problem if other data are being brought to it? So that's why you see that there are different evaluation metrics that are used. For that, when we are doing a classification model, you see things like accuracy and things. But for a regression model, you always see things like the mean squared error. The mean squared error. So what is the meaning of mean squared error? The mean squared error is calculating what? That is the FSE. So I'll be taking them one after the other. So let's take them one after the other. So this is your FSE, which is your mean squared error. So I will take this, then I'll take them down, then before we go on. So I want us to take note of what each evaluation of performance metrics they do. All right, so I'll start with the MSA, the MSA, the MSE. Okay, so I said the MSE is called mean squared error. Mean squared error. What is the meaning of the mean squared error? It is the average of the squares of your prediction errors. The average of the squares of your what? If you see the equation, I don't want to show us the equation here. Some of us will get scared. So let me not show the equation first. So we just talk about it. Let's talk about it. What is the goal here when we are using a mean squared error? What are you actually looking for? The lower your mean squared error, it means your model is performing very well. The lower your mean squared error, it means your model is performing very well. But one thing you must notice is that what it is always very sensitive to outliers. Why? Because it is the squares of your error. So let's say maybe my error is 0.02. What is the square of 0.02? It means that I'm saying what 0.02 was raised to power 2. You get it like that. So it must what? It must be low. If it is not low, it's not good. Whenever your model is performing. So it means that your model is not performing very well. When you calculate for a regression model and your mean squared error is very high, I think the basic mean squared error should not be more than 0.05 or thereabouts. Basically, I love using more, but there are times whereby you can't dodge regression models. I see a lot of people tend to run into what's it called into classification model because what you are calculating is just accuracy, precision, your recall. But when it comes to this, you are doing statistics. When it has to come to what is it, regression, your evaluation metrics are statistical. Are statistical. In fact, you can't run away. You can't run away from it. So you need to be very. No, I'm not moving the slides. I said it. I won't move the slides. I won't move the slides. When I'm done, I will move the slides. I said I'm talking about mean square error. Exactly. So I want to just explain. Please just try and listen very carefully. Okay. So that's it. But when you talk about your RMSE, so we have your mean squared error, then you have your RMSE. When you talk about the RMSE, it's talking about the root mean squared error. Root mean squared error. What does this mean? It is more interpretable than your mean squared error because it is in the same unit as the target variable. That's the good thing about it. It's always having the same unit with your target variable, but it will still penalize large errors heavily. So you must be very careful also. All these calculations, they must follow an error. I will state the ranges for every one of us. Range of your MSC. If it is more than that, you have issue. You have an issue. If it is more than that, you begin to fall into issues. So for your basic range, your range here for your what's it called? For your mean square error is always between zero. They say zero and infinity. But the truth is that what when you have a zero mean square error, it's a very perfect prediction. But I've always told us there's no how will I put it? There's no perfect model. Uh-huh. So if you predict and you are getting a mean square error of zero, you need to go and check your model very well. So that your model is overperforming or is underperforming, which you call overfitting and underfitting. But when you are having things like 0.05, exactly 0. It's still okay. Still very fantastic. Still very fantastic. Higher values for MSC, as I said, indicates what worse performance. Not told us. Then it's sensitive to what large errors when you are doing the squaring because every time you get it's always the square of what is the square of whatever you are putting. I got it. Exactly. So for even your what's it called, your root mean squared error also, it shouldn't be more than 0.0. Yeah, sometimes you can have 0.5, but the larger it is, depending on the kind of data set you are using and your model is different. But for every time, it has to just be between zero. For me, this maybe is between 0 and 0 point, what's it called, 0.5. 0.05 is fantastic. It's fantastic. All right. So I've just explained that why metrics matter. How do we know if our model is good? Metrics tells you how close our predictions are what to real life. You are trying to solve a real life problem. You're trying to solve a real life problem. So what is this? And what will be the purpose of this lesson when we are done learning? Somebody is asking what will be the purpose of this lesson when you are done learning. Can somebody help me answer Promise Okonkwo? Yeah, so both are very sensitive to outliers. The purpose of this your lesson when you are done is that you'll be able to build a linear regression model. And if you don't know how to evaluate your model, then why are you building a model? Or okay, let me put the example. How do Toyota cars know that want to make their car better than Benz or this that? You find out that what do you call it? When you look at Toyota cars, they are good for Nigerian roads. They are very rugged. You can use your Toyota car for 1 year and just service it just twice in that year. They are rugged. So you are looking. What are you looking for? Exactly. So that's just the reason. Somebody say, what am I using? Say, to evaluate your model to know its performance. Thank you very much, Paul. So the essence of this class is for you to be able to what? Solve real world situation. Uh, so solve real world. Okonkwo, I'm not sure. Have you been attending this class? Promise. Because I'm surprised that you're asking that question. I'm not sure anybody should be asking the question why you are doing AIMM and why you are studying linear regression. All right, let's go. Oh, I missed out to. Okay, I'll go back to it. I'll go back to it. I just saw that I wanted to cover some slides before time. So that I have about 30 slides. So if I can cover about 20, so that I will come back, I'll go back to it. Thank you very much. All right. So your mean square, as I said, you can see that I said I just want to explain before we go into the slide, because sometimes I realize that when we talk together, instead of reading the slides, so that by the time you now see the slide, it makes meaning to us. It's the average of the square difference between the predicted and what the actual values, like what I've explained earlier on concerning your mean square error. Then if your model says you will score 80, but you got 70, that's an error. Can you understand that for your mean square error? If you have created and said your model should be able to score, I predicted that okay, if I'm going to calculate what do I say, for how many hours a student is going to read to get a score of 80. And at the end of the day, you put in those hours into your model, and your model gets 70. Then what is the error between 70 and 80? You know that is 10. So you now calculate the mean and square it. So that's your error. So the error between, so your model should actually give us this 780. But if it's giving us this, it means that there's an error. Then what is the mean squared? What's the square of the mean between these two outcomes? So that's what it's just talking about. What is okay, praise, thank you, thank you, thank you, thank you, thank you, praise. I really appreciate it. Praise in your Lord. That's fantastic. Thank you very much for that answer. I really appreciate that. Okay. So this is your formula for your mean squared error. You can see mean squared error. Summation of what? Of your actual. So you first have your actual minus your predicted this. So you now square it, then divide by what? Divide by your n. Divide by excuse me. Excuse me. So you divide by n. I'm listening to you guys. How to? I've not forgotten. let's go on and explain how to. So your n is what your total number of that is your the score that you have predicted that you should get when you divide by it. So you now find out what that score is. So maybe it is greater than, like I told us, I always look out for 0.05, to 0.05. All you have answered, I will come back to our square. I'll come back to our. Let's hold that for me. So I don't miss a lot of things I have to talk about. So just like what I said, lower is always better. By the time you calculate using this formula, and what you get is between the range of 0 and let's say 0.05, then it's still okay. At least you said the model will perform by 80, and it gets 7, and it gets 70, and it gets a 70, then it means that what? It means that your model is performing very, very well. Is that good? Let me pause. If you have any question, then I'll go. All right. Somebody is asking what is n. I say n. N is your number of what? Sir, what did you say? Okay, what is the difference between? Just hold on, hold on. I'll talk about logistic regression. We're talking about logistic regression next week. So let's see learn graphs because this is one of the easiest regression, the linear regression. So let's see graphs, linear regression. And now talk about logistic regression. So let me answer those that are asking me what is n in the formula. So I say n is called the number, the total number of your data points, always known as observations in your test set or evaluation. So what are those observations? What are those characteristics or features that I've told you? Your input or that has how many features? Let me use the word features. I think it's best like that. So it helps us better. So how many features have you used? That is your independent variable for you to predict your targets. So that's what your aim is all about. You define meaning and fit means of correct. So that is what the end is talking about. What are those observations that I've done? Is it just the hourly during the hourly review? What are those things that you will put into the hourly review? Is there some routines and things like that? So your independent variable is the number. So those are your data points. Thank you. There should be the total number of the data points. Thank you very much, Yola. So correct. So correct. I really appreciate it. So example, using YouTube to test recommendation. So if you have bad recommendation, it means that there's more error. Like I was talking to us about Netflix and all those guys, TikTok. So if TikTok can give you, I watch Taliban, and it keeps giving me more of Taliban things, and I love it. It means that he has done a good prediction for me. It means that there's no less. But if he's giving me, I talk about Taliban, and he's giving me a brain daughter, what's this guy, very dark man, and those other guys. Then it means he has given me a bad prediction. Then it means what my mean square error is more. It's just as that. It's as simple as that. All right. Then your root mean squared error. It brings error back to the original unit. When you do your mean square, you have put it in another, it's not coming, it won't be in 80 or 70. You have divided and you have turned it to like percentages, will give you between 0.5. But so that you understand and say, oh, this what this thing is saying, for that guy, let me go back. For this person to be able to say he got 70, your model will not give 70. Your model will state this 70 in your what? In your mean squared error. It will give it in 0.0 something. So, but automatically, because you are using Python, you've already written the what's it called, the model. You have already written the model. Mr. Blessing, please help me answer the chat slide. I can see somebody asking some question I've already spoken about. Please let me answer them. So your root, so this your mean square will give us this error. For now, the error will not come at 70. It will give you in percentages or in float 0.0 something or 0.07 or thereabout. so that you will now understand what your error is in your target. You know, our target is that if a student reads for 8 hours, the student should get 80 and above. The student should get 80 and above. So what now want to know why we got that mean squared error. So it brings it back or brings your error back to the original unit, like scores or dollars. So by the time we do the square root of our MSE, that's why it's called root mean squared error. So the square root of our MSE will not give us that 70 that we found. Now, so now you now say, no, my model was supposed to say for 8 hours, the person's score should be somebody who has studied for 8 hours, the score should give about what's it called? Should give about 80, but now it's getting 70. So no wonder I'm getting that kind of mean square. And so this is what it means. What it means. Thank you, Paul and Mr. Blessing. Thank you. I really appreciate it. Mr. Paul, I really appreciate you. Yes, linear regression for numerical problem, but you'll be so surprised that logistic regression also can do numerical problems. Ask Mr. Blessing. In fact, if every model fails you, logistic regression model will never fail you. We are using it for both. Uh, so funny with the way logistic regression works. It works in linear models, it works in classification models, it works in clustering models. It's one powerful, it's a powerful model. It's a powerful, whoever developed that model did a wonderful job. Did a wonderful job. Did a wonderful job. So that's it. Okay. So this is it. Your root mean squared is just what the square root of your MSE. You know, as I told you, MSE easier to interpret than MSE. MSE will give you 0.0 percentages, but by the time you do it, it will bring it back to the normal value so that you can relate it to what your target. Oh, we're looking for 80, so what I got was 70. So it means okay, maybe I might still need to do some hyperparameter tuning in this thing, check some things so I didn't claim my data very or what went on that I didn't get something close to that. But if you get like 79, that's fantastic. At least 79 to 80, it means your error is still very low. So your model is generalizing very well. But now imagine that you predict that 8 hours should give 80. Oh, sorry, okay. Let me finish this sentence and we'll go for our break. 8 hours should give you 80 scores, 80%. And somebody reads for 8 hours and score 40. You know that's a very margin. The margin of error is just too is just too much. All right, let's take our break here. When we come back, we'll go on. Then I will not talk about the outsquare. And we'll go on with our other stuff. So please let's go for a break and take our attendance. Thank you. Okay. All right. Good to be back. Good to be back. I hope we don't fail our attendance. Then if I drink it, I have to go and take like 3 bottles of water. Believe me, when you're talking, you don't know that you're using energy. And in fact, the weather itself is not, it's not favorable at all. I was talking to you guys, I just felt my throat was just, it was as if it was coming. So it's just, I think I was dehydrated. So that's why I hydrate. So I hope you're all hydrated when I drink it. Please, let's try. I think somebody's laughing at me. It's straight. It's true. When you talk about the weather, humidity is so high, it's like a 40. You think you are under 40 degrees Celsius. It's just so bad. So bad. So but good. You guys keep us going. You guys have been interactive. You guys have been tweaking our brains. I love that. Your questions are fantastic. And one thing I love about you guys is that you guys ask questions. There's no foolish question or anything. It's so fantastic. Like I tell people, there's nothing like foolish question or stupid question. Question is the question. You don't know, you don't know. And when you already know. So I love you guys for bearing it out. All right, yes, thank you. Welcome back, Divine. Praise, Faith, Evans, Godwin, Cole, Anthony. All right, great to have everybody back. So let's go on with our root mean squared error. I was explaining to us that when we're talking about mean squared error, I was telling you that it gives us the marginal error, is the error between the outcome, your normal target, and the outcome of your model. But what it does is that it puts it in percentage because it divides it by the number of data points, which are your observations or the inference that you have put in trying to create that model. That's just it that way. Then when you now come back to the root squared mean, which is your RMSE. So your RMSE now brings it back by just doing what? Calculating the square root of your MSC. Calculating the square root of your MSC. Bring it back to a real value that you can relate with. Because MSC will give you a 0 to 0.05 if you have done very well. But how do you know is the number close to 80 that you have targeted? So root mean squared now converts it back to that your value, which looks like your target value. So that by the time you look at both of them, you're like, oh, my target value was 80. What my model did was 70. Okay, maybe if I do some other things, then I think it's still at least 80 to 70, there's 10 maximum between. But when it becomes a problem is when your target is like 80, then what you got or what your model outcome is giving is like 35, 40. Then that's a bit off. That's a bit off. Exactly. So if your RMSE is what? Is 5. Your prediction are off about 5 units. You get what I'm saying? That's a hair. So just imagine that your target value was supposed to be 80, just like the 80 that we have predicted. That anybody that studies for 8 hours is getting 80. Then your RMSE now says it is 70. You know that your prediction is off by 10. So 80 minus 70. So exactly, you get what I'm saying. So from there, you can calculate your mean squared error and things like that. So, but mean squared error comes before your root mean squared error. So, but the good thing is that in Python, there's already code for these things. So when you are doing that, Mr. Blessing was teaching us mean, median, and I think mean, median, variance, and standard deviation last week. So these are the things. So I think he will continue again this week, showing us how to create a linear model, then we will evaluate the linear model using mean squared error or which mean squared error. Then, all right, let's go to your R squared. Somebody was saying R2. It's R squared. R squared is always called what? Coefficient of determination. How much of the variation in the outcome is explained by the model? Exactly. Your model must explain the variation, you know. Okay, from the outcome I got, is your model explaining that okay, this is what has happened. Our target value was supposed to be 80. but we got 70. So this 10 that varied, what really happened? What really happened? What is it that I was supposed to do that I didn't do? You get it? But the good thing is, it says what? Yeah, what I really enjoyed is that for your aspect is always between minus infinity to 1. The higher your system explains your what's it called, your variance, it means that your system is generalizing. So that's why you see we are using all these metrics. So you can't just decide that because of one metric, my system is working very fine. No, no. It has to be a combination of matrices. What I mean matrices, performance metrics, using to check is my model working fine. So you can't just say because one, like that's why Mr. Blessing will always laugh at people that are learning. Somebody came one day and his model got 100%. Say yes, 100%. And Mr. Blessing was laughing. I was looking at him and said, why is Mr. Blessing laughing? Mr. Blessing said, come and see. Look at your sensitivity. You'll get to all those places. I'm just giving an example. Look at your specificity and look at your area under the curve. These things are far away from where it should be. And you're speculating that accuracy is 90. There's something is wrong at the other end. Then your model is overfitting. I was there, me myself, when I looked at it, I was just arguing with him. I was like, yeah. So I said, give me the data set, give me everything. I want to try it. When I called, he said, I was telling you guys were saying the model is fantastic. I said, have you forgotten that the model can never be 100%? In fact, there are other criteria attached to it. So it shows. So when your R squared is equal to 1, it means that you have gotten a perfect prediction. It will use your R squared will always work on both your what's it called, your MSE and your root squared MSE. It will look at what they have done and not tell you, okay, if it is 1, if the outcome of your R squared gives you 1, it means that you have done a perfect prediction. If it's equal to 0, your model is not doing any better. It's just predicting the mean. And if it is less than 0, then your model is what? It's just nonsense. It's not a, in fact, it's worse. It's a bad model. For every time you are creating a linear regression model, your mean squared error is between 0 to 0.05. It's fantastic. Your your the square root of your, which is your root mean squared error, also is not, it doesn't vary too much. It varies, as I told you, maybe you have your target value as 80 and your outcome is 70 and it's 10 in between, it is still okay. But your R square will now look at it based on what you have done all over the whole, what's it called, all over the whole what's it called, your data set and your model. It now looks at it and says, oh, okay, based on what I've seen, on the how much variation in the outcome, this model can interpret, okay, and interpret very well, can even take on external data set and still perform and do the same thing. Okay, then the model is working very, very, very fast. So those are the things. Somebody is asking, is metrics the same as threshold? Is metrics the same as threshold? Anybody wants to try before I go on? Is metrics the same as threshold? Who wants to answer the question for us? I'll pause. Hey, somebody? Okay. Great. 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 Who's trying? Nobody. Okay. Somebody said no. Thank you very much. They are not what? They are not the same. Metrics are what? For performance. Threshold is always talking about between two variables. Just like when you are doing a probability between a variable. So that's what threshold is always looking at. Maybe in a binary classification, we are looking at diabetes mellitus and non-diabetes mellitus. So if your threshold is like maybe your probability is 0.92, then your threshold is like 0.5. Then it means that the capability for your model to predict class 1, that's what there's a diabetes mellitus, should be greater than what 0.5. And if it's for class there is no, then it should be what less than. So you can't use threshold. Threshold is always good when you are doing binary classification, and maybe you are using it to check the class membership. When I mean class membership, what are the two classes? You have sick and not sick. So it's like a probabilistic. So don't it doesn't most of the times I don't usually use it. I use precision or record. So I usually use precision and record. So most of the time I think statistic people use thank you metrics to understand how well a model. Why threshold is to look at the probability of predicting between two classes. Thank you very much, Mr. Oji. I love that. I love that. So your metrics is just to understand how well your model is performing. Then threshold, maybe you have classes, you are classifying two classes. Threshold is just telling you, okay, how how can this your model, how will it be able to classify between those two classes? What's the probability of classifying those two classes? Yes. When something means as a certain exactly means a certain condition. Thank you. Can it classify can your model classify very well for class of diabetes mellitus or cannot classify for two? That's just it. Somebody said, is it non-pi library that is used to calculate? No, there's a library. Mr. Blessing will be talking about your libraries for metrics. For metrics, yes. You are going to be doing that this Friday, so let's just go one step at a time. One step at a time. All right. So I can continue. I say what? It ranges from what? 0 to 1. For me, I say minus. I always like to use minus 1 to 1 because your model will be a perfect model when it's 1. When it's 0, your model is explaining nothing. Then when it's minus 1, your model is underperforming. The standard is say between 0 to 1. But for those of us that have been working on machine learning and AI for a long time now, Mr. Blessing will always tell you when it's underperforming. It's not even apart from explaining nothing, your model is just doing it's not in fact it's not doing what it should do from the beginning. At least the model has done something. It has been able to calculate the mean squared error, calculate the root mean squared error. Then it now comes to calculating your determination, your coefficient of determination, to be sure that okay, is my model explaining, be able to tell okay between the target value and whatever actual value it was, and we relate them. So if you get a 1, it's a perfect model. When you get 0, okay, you can still work on it. But when you have -1, then in fact that model should not leave your laptop. You just need to break it down. I'm going to look at it. You see that I didn't, is there a kind of class imbalance in my data set? Something, somewhere. Exactly. Metrics tells us how close we are to our predictions and to real values. Thank you very much. Thank you very much. Psychic learn, yes. Library and report your metrics. Yes, fantastic. You're correct. You're correct. Thank you very much. Those that are helping me to answer the question. I can answer all questions, but I prefer that we listen to this class. When you come to metrics area, it's not something that is difficult. But if you don't know what is going on underneath each evaluation metrics, you'll be so surprised that you'll be doing a classification model, you'll be using metrics for regression model, and vice versa. So it's always good to know the concept. But when it comes to practical class, it becomes better for us. It's good, but asking questions I love what you guys are doing. So let's now. We're almost through it as but I'll take it as slow as possible so that then I'll have time for more questions so I can answer questions first. All right. Example. An example. Think of R square as your net rate match percentage. The higher, the more confident the system is that you will like exactly. Just like when I was telling you, prediction model, the more suggestion it gives you, and you look at it, oh, these are wow, these are things that maybe I've been watching it. Like I started this series ago. I think I saw I watched it about we are now in 2025. So 2011 is about 14 years ago. Supernatural. Yes. I don't know. Most of us, I'm sure you have seen Supernatural. It's like X Files. X Files is a bit older than Supernatural. All right. So I was watching Supernatural. In fact, I think I'm in season 5 now. When I have leisure time, I do see some movies like that. So I was thinking. So today when I logged on onto my Netflix, it was suggesting X Files for me. All right. And when I saw, it's the one that I watched X Files. Immediately I went and clicked it and put it in my favorites. So that's what this example is just talking about. If I'm looking for I watch a film and Netflix pops up and that one and it matches my desire or matches my preference, then it means that what I will like the movie. There's no way if it matches what I'm looking at because Supernatural is more of like horror and all these metaphysical things like angels and demons and God and everything. So it's just that's what Houseplant does. And the system explaining what it has been told to do. If your value gives you one, it's a perfect system. I keep on saying there's no perfect system. But just use the word perfect. But if it gives you zero, your system is doing nothing. The system is doing nothing. Then if it gives you minus one, I just say put it down and start all over again. I don't even try to tweak anything again. Just start from the beginning. R square is not part of unsupervised learning. R square is an evaluation, performance metrics or evaluation metrics to check if your model is performing very well. R square, MSE, RMSE are used to evaluate a linear regression model. After you have predicted now I told us to state examples, and you have done your prediction, you now want to know this prediction can it be compared to real life exactly? But that's a new word. Can my prediction that I've done can it be compared to real life? Then we calculate the MSE. That means the closer you are to one, the better the performance of it. God bless you. God bless you, SHG. God bless you. And the farther you are from one, then you know what's happening to your model. Thank you very much. So that's just it. That's just it. Yeah. You're fantastic. Thank you, Emmanuel. I hope I pronounce your surname very well. SHG. I'm not. I'll give you a card. Don't worry. Good, 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 good. Are these metrics only for linear regression model? No, you might decide to choose them based on the kind of data set you are using. You can one good thing you see one thing about evaluation metrics is that if you can adapt them to fit your model, but anything that when anything has to do with linear regression, I think it's always best to just use this like the basis, anything that has to do. You're looking at this a straight line. So it's easier instead of it going to now be calling accuracy and all this recall and things. So just it's a long thing. This one tells you just three matrices, tells you if your model is performing or not. All right. So I think what we be able to do is that we'll be able to sit down to do good research so that we don't have the problem that when we started learning, the problem we had before we know what evaluation matrices were and things like that. We had to go through a lot of trial and error. So we need to do research for each model, the best performance and metrics that fits them. So that's what we're going to be teaching in this course. So that it makes your life easy. You don't need to start doing trial. And error. Okay. So that's the formula for what's it called? The R squared. Which we have for R squared. So Even though what I'll do is that the this is not looking, so sorry about it. Sorry about this. I'm going to be putting it into a formula so that you will see it very very well. So put it in formula format so that you can understand what's actually going on. So that's just the basic example I've just explained to us. It's just, so other models have their own. Yes, yes. Oh, I pronounced it well. Oh, you want cow? No, I'm not giving you any cow. Manuel. Don't worry. great, great. I tried. I tried. That's good. Lucky I pronounced the name very well. I don't want to mess up people's name. All right. So I'll pause a bit. If you have questions, ask me, then we'll go on. How about our five slide left? So if anybody has a question, you can ask. We'll go on. And yeah, please explain the formula. Oh, all right, I'll do that. Please explain the formula. I'm here. I just came in from work. Okay, please. Oh, Steven. Wow, I didn't notice. Sorry. Again, I didn't notice that you're not in class. Sorry about that. Don't worry, you watch the video. You watch the video again. You watch the video again. All right, let me answer talk about the what's it called, the parameters. And we'll go to the next slide. Sorry, I'm starting very slow. I don't know if it's so good. So I can do it. All right. So your R square, which you already know, this is your R square, which is one minus your SSN resolution. What is your SSN resolution? The SS I say resolution, residual. SS residual means what? Residual of your sum of your squares. I don't want to put all those further mathematics formula so I won't be scared. Summation of n over summation. You have I is equal to 1, then you open brackets, y underscore I minus y underscore square. So it's just telling you residual. When you see SSRES, residual sum of your squares, what is it doing? It just measures the total square differences between your actual value and what and the predicted value. So for every value you get, what is the total squared difference? So when you remove, maybe I said 80 should be my target. But what I got was 70. So I just say 80 minus 70. Then what? The square, the square of that pen is what is called what? Your SSRS, your residual sum of squares. Then you now have your SS dot, which is your total sum of squares. This measures your total variance in the actual value. As some Mr. Blessing was teaching us how to calculate variance. So you calculate the variance from your values. What is the total variance in the actual value? That is what SS dot is. So 1 minus residual sum of squares, which is the total square difference between what your actual value and the values divided by what the total variance of your actual value. I'll repeat that again. SSRS is what residual sum of squares, which means what the total square differences between your actual value and the predicted value divided by what the total variance in the actual values. So don't let your mind don't get scared of what I'm saying. Python is there to help you. So mathematics and physics. So Python is there. Python is there what's it called? To help you do that code. So you don't need to be writing the summation of this thing over this. You don't need that. Just the lines of code in Python, and you're already doing that. What is the relevance of this linear regression to AIML? Please, can somebody help me out? Somebody, I think I've spoken about the relevance of linear regression today. So help me out to answer that question. Amarachi Grace, thank you for this, what you have done, threshold and the matrix. I appreciate you, Amarachi Grace. Praise, yes, mathematics has really, yes, mathematics, physics, statistics, they are really done very, very, very well, very, very well. Why is AIML always following the binary communication? Yes, now, like we know that our system, what's it called? The computer recognizes what numbers, zeros and one. So you must feed it. Physics AC circuit. Yes, thank you very much. Thank you very much. Thank you very much. So you must feed the computer with zeros and ones. The computer does not understand the English you are speaking, even though you are programming in English that is like lesson has spoken about. So it's very easy, it's like your English. But by the time the interpreter is interpreting to the machine to understand what you are doing, it's sending back the signal in zeros and one. Zeros and one. But that's basic computer science. Basic computer science. Don't get scared of Mr. Davidson, we got help us to understand. there's no there's nothing in metrics. Metrics is just to understand what am I calculating? What metrics goes for what method? Every of these formula here, there's a way you write it in Python. There's a way you write it in Python. So I don't really understand this formula. I need please explain again. All right, I'll explain again. I say R square is equal to no ML is not pure applied statistics. So let's not go and scare people. We are borrowing from everywhere, everywhere, from physics, from math, from statistics, and so yeah. So I won't say SS total. I explain SS total. I say the total variance of the actual value. I saw Mr. Blessing teaching us how to um, calculate mean, median, and talking about variance, standard deviation. And so you need to go back to that video. The way they arrange and write the formulas could be very intimidating. But that's just it. That's just it. But when you know the concept behind those formulas, please don't scare, don't make anything scary. Is used to measure the performance of yes. Those are the things used to measure the performance as well. MSC, the RMSE, what's it called? And the linear regression is a way to find the best token that shows how one thing affects the other. Exactly. How your independent variable affects what your target variable. What has Mr. Lamide been doing to make him this fat? Is it that he eats too much, he sleeps so much, and he doesn't exercise? Independent variable against with this was this algorithm. I said this SS total, variance, calculate the variance of your values in your actual targets. That is what your SS total is. Mr. Blessing will make it clearer when you start doing your calculation. I think we are certainly the Python files and everything for your practical. So you see them on Friday. All right, let's go on. Okay. So that's what I said. I said I usually want to talk about it. Okay, then SS residual. I said it's the sum of squares of your C of your residual. So you can see it here. SS residual that you're asking about, also called residual sum of squares, your RSS. It measures how far off your modest prediction are from your actual value. You know, that's what I've been explaining to us. All right, thank you, Mr. Wadi. We appreciate you, sir. All right, so let's go. Let's go on. All right, so it measures alpha. When you talk about residual, I told you you're not calculating what you're calculating the total. This is my actual value. 80 was the actual value we are looking for. Then I got 70. If I say 80 minus 70 is 10. So how far is that from That margin, how far is that from my actual value? So I said the lower is what? It means your model is working fine. So if my target variable was 80, at least 80, 70 to 80, it's still like 10 steps. But imagine somebody whose actual value was 80 and it got 79. You can see that it's very low. So it means that the model is really working fine. Now imagine it with somebody whose target variable was 80, then is not getting 35 as his actual as his prediction value. Then you're wondering what is going on, what is going on. So that's too far away, too far away from the range that he or she should be getting. And that's thank you very much. I can see people answering questions which I really appreciate. I really appreciate. I really appreciate. Thank you. Thank you everybody. Thank you. Thank you. Thank you. Yes. Thank you, Paul. He has the ability to model relationship between variables and make predictions. Thank you. That's fantastic. That's fantastic. It means that listening in the class. Thank you. Thank you. Thank you. Thank you very much. I really appreciate it, class. Okay, let's go to the next slide. Then I spoke about your SS portal also, which I was in paper sum of squares, which it measures how spread out the actual data points are from the mean of the actual values before modeling. All right, all right. Don't worry, Flame, Spirit. They will share you the new link. We have combined or compiled all lectures till now. All lectures that you have done till now. That's this should be lecture 10. This should be the 10th lecture. And all your Python practice files that you can also, apart from the ones that you've done in class, that you can practice on. We have actually uploaded it. So I'm sure that admin will send us that link. Then you can find all lectures from previous classes till today. Everything has been uploaded. Find you find everything. Exactly, you code them as your part of. So by the time you are calling your library, you'll be calling your SK learn and things like that, your psychic learn. So you call your metrics, evaluation metrics, all the metrics you want to, just like the way you call your math from B and things like that. So it's in the code. So I said about our SSM total. So I said it measures how spread out the actual data points are from the mean of the actual values. I said it represents the total variation in the data set, the total variation, which is your variance. Assignments. Admin will talk to you about assignments. I think your LMS is ready or is ready now. I think you'll be getting your what's it called? Your assignments on your LMS. So I think you'll be working with that. So don't bother about that. You have sent your assignments in. In fact, I've sent assignment for week 1, week 2, week 3, and this week. So I think it will come. Week 1 and week 2 is they are very simple. Don't bother yourself. Who I've told you, assignments will come from the LMS. Just answering the person who has asked us. You will be assessed now. You need to assess everything that we need to be sure that. So we also can know okay, maybe there are areas we need to touch, your mentorship and things like that. So don't be scared. Assessment will come, so it's not so bad. It's not so it's not so bad. How do I work with a data set that is solely text or strong data type? I think Mr. Blessing did that in the last class. I need to go and watch it. So imagine people they ask for assignment. Yes, people will ask for assignment. All right. Okay. So thank you, Mr. Emmanuel. Please check your mails and onboard with the Canva LMS. All assessment will be sent here. Thank you very much, Mr. Emmanuel. I really appreciate you. I really appreciate you very much. So everything is set. One thing I just love about us is that I see that we are following. Just know the theory behind it. You don't need to cram any formula, as our tutor told us, Mr. Pearson, and Mr. Pearson told us when he was teaching us. Don't cram any of these things. Just know the concept behind them. Know when to use them. Then go and learn how to use them on the Python. As simple as that. There's no, so it's not just to scare anybody. But one thing I do is that you must know the concept behind what you are using. So that when somebody even sits down with you and is reading your code and is asking you why are you using this metrics, then you should be able to you'll be able to really explain exactly because it doesn't look good on you. I've seen people that code very well, very well. But when you ask them what is this code doing, he knows what it is doing. But for him to relate it to you is very difficult. So it's one thing. Like I always say, you need to go over and over and over again. If something is your passion, say take the price also strong. Thank you, Paul. Thank you, Paul, for that. I appreciate those that are helping me to answer questions on the chat. All right. Okay. Okay. This is our last slide. This is our last slide for tonight. And I'll answer all questions quality again. So performance metrics that I've spoken about today, your mean squared error, analyzes large errors, that is large margin. Best when you care about big errors, exactly. Why are we using your root mean squared error? Because when your answer comes in your mean square error, it's coming in percentages or in yes, in decimals. So you can't really understand wow is how can I relate it to the target of 80? When I say my target is 80, this converts it now to to look like your actual what's it called, your actual value. So it does what the square root of your MSC and changes it from a decimal to a whole number. Then your R square tells you the percentage of variation displayed. Exactly. So when you can see where you use them. You want interpretable units for RMSE. For your R square, you need a model overview. So you see that these things are metrics. They just give you a full picture of what you have done, so that you are even sure, okay, am I doing the right thing? Or it's not canvas, it's canvas. This is canvas, it's canvas. Right. Somebody says canvas. Right. I think it should be canvas. I'm not sure it's canvas. It's whichever is fantastic. Just try and make sure you log on and pick your assignment from that area. So all these notes are already uploaded for you. Everything has been uploaded. All you need to do is just go through them. But one of the things is that every practice folder, I think I put about 10 there now. I'll still add more tonight. I'll keep adding more for you. And we have labeled them. You want to calculate mean, blue squared mean, you want to clean your data set, you want to normalize your data set, you want to solve. Can we use two performance metrics? Yes, now you can use more than two. When I'm doing classification models, sometimes we use we use about seven sometimes. So it's dependent on what you want to read in your model. What do you expect your model to do? So you can use more than two. You can use more than two. And it's more specific. What's it called? Specific rule. But the good thing is that the more performance metrics that you use, the better your model interpretability. So you can interpret your model. People can look at your model and say, "Oh, wow, this is uh, this is what this model is." So you can see what I said. First, when you care about big errors, you want to know what are the errors in my model. MSE. I want to interpret that to a unit that everybody can understand. RMSE. That's for linear regression. Then I want to see everything that has happened from the beginning of the model. And that is what your R the square, your R square. Is it for AI or ML? Is all this calculation? Is it for AI or Python? It's for everything that you have mentioned. Yeah, you're studying AI ML. It's useful in your email and you personalize it in your Python. So you are correct. You are correct. All right, Esther, talk to admin. You can talk to admin. Admin will help you out. As Mr. Blessing already said, AIMM is not for the faint-hearted. You must be rugged. You hear him saying, you must be rugged. Uh-huh. Because that's where the world is turning to building solutions. People ask you now, you don't go for interviews, and somebody is asking you, what is your qualification? What is nobody's asking you that. What can you do? In fact, if you are not careful, somebody's asking you your portfolio. And that's why we put in this what's it called? In this course, I told Mr. Blessing, everything you are going to be doing is going to be showing you how to create a portfolio. And after you finish this training, plus your project and everything that you have done, all the videos, man, you can still watch your videos on YouTube. They are all on YouTube. Every video that we are doing, they are being recorded. They are on YouTube. It stays on YouTube, so you can go and check what's it called, Incubator, video up and subscribe. You see all the videos of your class that have been taught. Is it possible to integrate and deploy more than one? Yes, now you can do that. You can do that. Specifically based on what kind of problem are you trying to solve? So please, you can. Yeah, on YouTube. Thank you, Daniel. Thank you. Please advise us on how to shoot from graphics design to ML. Admin will help you out. Admin will help you out. Let's talk to Admin. Admin will help you out. So that's the reason. AIML. Yes, the field looks very stubborn, but there's nothing difficult in it. I see people coming from economics, coming from accounting background. They are doing very well. So it just takes time. What I believe is learning is how will I call it? It's progressive. Uh-huh. What are the metrics for classification model? I'll be teaching you that next week. I'll be talking about classification model. So we'll be saying about metrics such as accuracy, you have recall, precision, reference, or your area under the company, which you call the AUCROC. You have your sensitivity, you have your specificity. So we're talking about that today. Thank you, Mr. Emmanuel. Thank you so much. Thank you so much. All the things are good. Thank you so much. Thank you. I really appreciate it. So, is there another question? Well, about 7 minutes. I think I'll be able to answer each other question. Is there any other question? Okay, like I started. So I think for those that came, some people yesterday they came in. So I'm going to repeat it, which I'm going to be talking about on Wednesday also. Preparation for our projects. What are the things we need to do? So I think I mentioned them this evening when I started. By now, I think everybody now should have data sets. You should know where you can get a data set. Let me quickly pinch our brain. I need about 10 people. Can you tell me two places where you can get data set now? Two repositories where you can get data set. Can you just quickly write it and let me see? So I want to be sure that we know that where we can get our data set from. Two public repositories. Cargo, fantastic. Isaac. Which other one? I want to see another one. Everybody say cargo. Nobody is saying something else. Let me see. Anywhere else? Cargo. I still see cargo. 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 Data.org. Great Bola Joko. Great. Hugging face. All right. Great. GitHub. Thank you, Divine Favor. That's fantastic. GitHub. All right. So it means that we are following now. So by now you should know what problem. Oh, thank you. UCL for machine learning. Fantastic. Esther Bamidele. So for now you should know, okay, what problem do I want to solve? Then you should know your problem statement and write down your problem statement. Then you should be thinking of what solution to the problem. What solution do I want to provide to that problem that I've seen? Then you should have your data, Google data search. That's fantastic. Then you should have your data. Esther Bamidele, thank you so much. That's fantastic. You have Mendeley data also. And loads of places where if I just go to your Google search, like somebody has said, I love that your Google data search. I just type data set for maybe whatever you're looking for. But before you do that, exactly, God bless you. You can do primary survey. It takes time anyway, but it's a good one. You do it electronically and you can send it to people. It's fantastic. It's fantastic. Yes. Global Health Observatory Data Repository. Yes, TV. You guys are wonderful. You guys are wonderful. So I just want to start preparing our minds so that by the time we meet in the next class, when I'm discussing NCBI, that's fantastic. When I begin to explain and talk about your model for your model what's it called project for your project. So you should have your data set now. You should know your problem statements now. What is the solution? Then what model are you going to be using? Then based on your data set, exactly. That I'll be teaching on Wednesday. How do we choose models? How do we know what model is best fit for whatever I want to do? So those are the things that should be running through our mind now. Even though I know you are trying to grasp concepts, still working little by little. But those are the things that form your curiosity, that helps you so well. So you need to sit down, get a notepad, and start doing your own little scribbling. What the openly available is great. So you need to start doing your own scribbling. What do I want to solve? I don't think it's everybody that wants to solve health problem. Yours might be spam, might be fraud. So what do you want to do? Yours might be finance. Like somebody was talking about employment attrition rate. So somebody writing that. That is a linear regression model, so which is fantastic also. So you can build that, you can do a bit of visualization and things. Maybe it's weather forecast and things like that. So NASA open data, great Francis. That's good, that's good. So but somebody I love Afolabi said we can get any data set. Can we get any data set of cryptocurrency? You can search. You can search. I, I basically work on health data sets, but I think Kaggle has exhaustive number. Just type it on your Google search, and say cryptocurrency and blockchain data set. It will direct you to the right path. If Kaggle is part of it, it will give you Kaggle first. Every time you do that, it will give you other ones that are also relevant. Like one now, I was asking for a data set I wanted to use for Wednesday. They have to send me an agreement I need to sign. I signed the agreement. After the class, I'll send it back to them. Then they send us the data set, which I'll send to Mr. Blessing also. It's a very good data set also that I think that you can use for your practice. So it's a wonderful data set. So there are people that need you to sign agreements for data set. So thank you. I can see that we are all good. Good. It's good. We know where to go. We know what we are doing. Yes, I know that some of the theorems might look abstract, but don't let them scare you. Have an idea of what they do. Like what I say, you don't just get into a car and start driving the car. If you don't know where your clutch is for a manual car, your gear, you don't know the gear, which one is gear one, the reverse and neutral and every other thing. You don't know where to brake and system. So that's what we are doing at the moment. You find out that every jargons, like my prof will always say, that I've spoken about, and how you get into your Python environment, it just starts making sense. I see somebody in the last class say, everything is already you was saying, since that blessing has played it out. I was laughing. I was so excited. I was so excited about it. So don't let it scare you. Go back to the videos, check on them. So it's good to have everybody here today. You guys have been fantastic. I'm telling you. After week one, everybody has been fantastic. I have to say that. All of you, no questions. Every questions I've just been taking my brain. You make me go back and read more, research more. So I tell you, you guys are wonderful, wonderful guys, wonderful guys. And I know that by the time we are going to be completing these courses, I'm going to be seeing wonderful portfolios, fantastic portfolios from you guys, wonderful experiments from you guys, models that you know that people will look and say, yes, this is fantastic, fantastic. So good having everybody here tonight. So once again, I say have a great evening and good night, everyone. Bye. Bye.